All right, so we're looking at Dijkstra's algorithm, and we want to find the length of the root of the shortest possible path between vertices A and F. All right, so we're going from A to F. That's what we're looking for. So step one is to actually set up your table. So you're going to do like this, like so. A is going to go in your first row. And then you're going to put all your other vertices along the top as your columns. And it should start to look a little bit like this. A, B, C, D, E, F. Cool. So that was step one. Step two is we are actually going to now go through and do for your row A, all right? And you're going to list all the connections between A and the other vertices that you've got along the top here. All right, so from A to B, what connection do we have? We've got this one here, all right? So it has a weight of 1, so we're going to put 1 in there. From A to C, there's no direct connection. It only goes through other vertices, so we're going to put a cross there. From A to D, we do have that connection there of 4. Then from A to E, we've got a connection there of 7. We're going to put that one in. And from A to F, we've got this one around the top, so we're going to put 9 in. So now we're up to step 3. What you need to do is you need to identify the smallest number in that row, and we're going to put a box around it and copy that down into our next row. Right, so we can see that 1 is our smallest weight, so we're going to put a box around that. We're going to bring that down here, 1 with a box around it, and that is in column B, so we're going to bring B down as well. Now, we complete the second row. Now, there's a few more steps involved when we get to the second row, and I'm going to talk through those as you go. Just pay close attention. Now, we're looking at row B, so we're looking at all the connections from B. All right, so now we got from B to B has been done, so from B to C is what we're looking at next. So the connections from B to C, are there any? Yes, 6, we can see that there. So we're going to go 6 plus the previous value in the box. So that's 1. So we get 7. So 7 is going to be put in here. Now let's go from B to D. All right, from B to D, is there any connections? No, there's not. So we copy down the number that is above. All right, and we've got a 4 in that row. Or column rather. Now from B to E, we can see there's no direct connections from B to E that don't go by other vertices, so let's copy down the 7 that's already in that column. Next, we're going to go across to from B to F, no direct connections there, so we're going to copy down the 9. Once again, we are looking for a non-box number to copy down into our next row. All right, and we're looking for the smallest one. We can see that 4 is the smallest, so let's put a box around that, bring it down to here, and put a box around it again, and we also copy down any other box numbers. All right, we just copied down D, or identified D as the smallest number, so we're going to put D in here. And now we continue for this row. So now our row is D, right? We've copied in D. So now we can look at all the connections from D to all the other variables that don't have a value. So D to B has already been done. From D to C, let's have a look. From D to C, we've got a connection. 1, just here. So 1 plus the box number we just brought down, which was 4, equals 5. All right, so it's 5. Now, it is less than our number that we have above, 7. So 5 is less than 7, so we bring 5 down. All right. If 5 was bigger than 7, we'd bring 7 down, but we're going to bring 5. There we go. Continue on. D to E, there is a connection of 2, so 2 plus the box number for D is 4, so 6. 6 is less than the 7 above, so we bring the 6 down. Cool. And D to F, there's a connection of here, which is 5. So 5 plus 4, we get 9, right, which is the same as the number above, so let's leave it as 9. Cool. Repeat the step again of boxing the smallest number, 5. Bring that number down, 5, box it. That's in column C, bring C across, and copy in all the other boxed numbers, like so. And now we repeat the process for row C. Right, so looking for the connections for all the left numbers, so we've got E and F. So C to E, do we have any connections? So C to E, which is up here, no direct connections. So as there's no direct connections, usually we put a cross like we did up here, but because we've got numbers before it, we're going to copy down the number above. So we copy down the 6. Now C to F, we have from C to F, we've got a 2. All right, so 2 plus the number of this column, C, so that is just here. 2 plus 5, we get 7. All right, now that is less than 9, so we're going to bring the 7 down, and that's going to hold its place there. Once again, look for the smallest non-boxed number, which is 6. Bring 6 down. That is in column E. Bring E across and bring down the box numbers. Now we look E to F. E to F is just here. So 3 plus our box number for E is 6. All right, 3 plus 6 we get 9. But now 9's bigger than the 7 above it, so we bring the 7 down. Final step, box that number. Bring that down. And now we have completed our Dijkstra's algorithm. Now we need to backtrack. So to find the shortest path now, we start at the final destination, which was our box number for F. All right, we were trying to get from A to F, so we're going to start at F and we're going to work backwards. What you need to do is you need to start at the number there, and you're going to draw a line, a vertical line up, so that's a value of 7, up to the last 7 in that column, all right, which is here. What you then need to do is you need to look at the column that it is in, so it's in F, but we want to look at the row. So here's the row here. So it's in row C, so we're going to draw across until we get to column C. So all the way across, column C. There we go, we're in column C. Its value is 5, so now we're going to draw a vertical line till the last 5. Cool, that is in column D. So now what we need to do is draw across to column D. Across here. And then we draw all the way up to the last 4. And as we're in the last row, now we draw across to the starting vertex of A. Now, your shortest path from A to F is going to be all your horizontal lines or columns. So, we start here, A. Then we have a horizontal line here, D, horizontal line here, C, and then we finish at F. All right, so our shortest path is going to be A, D, C, F. And its length will be equal to the value in the end vertex F, which was 7. So its length is equal to 7. Great, you completed Dijkstra's algorithm.